So you can see here what I've done. I've basically welded in the pin. So now I'm going to give my car an intravenous drip with my oil filling contraption. So, but I'm going to go a bit thicker, go for 140. So that's kind of in the middle of the range of possible things you can put in. So it doesn't actually take that much. So we'll just do this a little bit at a time. So I've wedged that in there, level. Let's see if the seat still fits. Okay, well, it does fit. It's not quite up against the bulkhead either, so there's about 2 inches clearance. Okay, so I've been and bought a battery. There's my model. There's the real thing. It's this AGM. Which basically means it doesn't leak even if you turn it upside down, and it probably doesn't leak much even if you crack it. So I've got to make a battery box, got some steel, and take the sides off the car again. I'm going to have to weld it in down there. So that's the next bit of fabrication. So I just drew around the battery on my temporary bench here and measured everything out. So I'm welding it up bit by bit by bit. I'm building it up basically from bits of steel bar. So here's my final creation. It welds in at 5 points. Point there, here, 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 just there to the frame. So if I go and try and test fit it, you can see so I'm going to put a couple of tacks, then put the battery in, then check the seat fits. I've tack welded it in. So I'll put the battery in now and see if it's in the right place. Will it fit? Will the seat still fit? And then if it does, I'll finish off the welding. It's a pretty good fit. So the next thing, put the seats in and just see how much clearance we've got. Looks alright. Let's go on the other side and have a red look. Oh, tons of space, look. Not bad at all. And that's great because that can come up, go through my bulkhead connector, which is still on order. Then that'll come round up to here and then join in with everything else I already made. That's a bit of a relief, isn't it? Right, now I need to finish off the welding and do it properly. My gearbox is now full. See, it's overflowing, dripping out. So that's another job done. The other thing I'm going to test today is my rev counter. This is a hall sensor. It kind of will turn on and off whenever a magnet passes by it. So it produces pulses basically. So I'm going to strap a magnet to my electric drill and then see if my RPM counter here reads anything believable, and then if it does, the magnet is going to go on to the end of the crankshaft deep in there where the old crank handle would have gone. I've got the sensor here. I've got a drill with the magnet attached to it. So if you watch the gauge, when the drill's flat out it goes at just under 2000 RPM. You've still got to hold it fairly close to start off. Now, you know, sometimes when you're asleep you wake up in the morning and you've got a good idea.
By George, Wiley, you've done it this time. You genius, you.
Well, I think it's a good idea. I've got this sensor. I tested it with a magnet attached to my drill, and I know that it does work. It's a magnetic sensor. Every time a magnet goes by it, it sends a pulse. The trouble is, you've got to mount that magnet to something. Now, I could grovel under the car, like this. Where are we? Yes, and grovel under the car. I can fit a magnet to this, the end of the crank here, where the old crank handle would fit, and then a bracket with that sensor on it. But of course, removing the under tray here, the underbody here, is perfectly possible, but it's a bit tedious, because every time you take it off, you've got to also undo the exhaust and then match them back up when you put it all back together. It's a bit of a pain in the backside, so the less times I have to take the underside off, the better. So I had a brainwave alternator pulley. It's made of aluminium. So if I fix a magnet to this and fix the sensor to my steel bracket here that I had made, I can weld some sort of thing that bolts on, is removable, that holds the sensor sort of there. The thing is, because there's some adjustment in the system I got behind that dial, if I know that one revolution of the engine is sort of 1.4, say, turns of this pulley, I can compensate for that, so then I get the revolutions per minute of the engine again, or pretty close to it. So I'm going to paint a dot on this, dot on my the end of my crank, and then with a big spanner I'm going to turn the engine one revolution, see how many times this goes round. So I've turned the engine an exact half turn, and you can see you may be able to see the mark, which should be at the bottom, has come round to here. So it's about 1.2 turns of this to one turn of the engine. This is where my favourite cheap tool comes in handy again. I've put a mark on the top, level with the 0. And then if I shove this, see, there's also a mark there. So if I put it down here and line this mark up with the line on here, it'll tell me how far past it should have turned it. If the pulley was the same size as the engine pulley, it would have turned half a turn, but it hasn't, it's gone more than that. So if I line the line up here with the line on the pulley, which is about there, then it will read off, there's naught. It's turned about another 60 degrees or so, so it just fits down there. You've got to get in the middle of the pulley, otherwise it doesn't mean anything. And you try and line the two marks up, and you try and look there. So the mark's about lined up anyway. It's about 62 degrees. It's Saturday, there's lots of people doing DIY, which is good because it's not just me making all the noise for a change. So what have we got? So if we turn the engine pulley 180 degrees, half a turn in other words, the alternator pulley goes around 180 plus 62, because I just measured that. So that's 242 degrees. So it goes around more, which is kind of what you expect, because it's a bit smaller in diameter. So if you divide 242 by 180, you get 1.34. So 1.34. So basically, if I take my rev counter as it's set up at the moment, get the revs per minute from the alternator pulley and divide them by 1.34, that gives me the true engine revs per minute. So there's my hole. I drilled it to the depth of 2 of these little cylinder magnets. They're very powerful, they're neodymium magnets, you can buy them online. Just put neodymium magnets. Right, there's my depth gauge, which is a piece of tape wrapped around the drill. If you look, it's It's exactly right, allowing for the tapered tip of the drill. And we have some industrial super glue. So the idea here is I've welded this to the Y-shaped mount. We've got two captive bolts. This weird shaped piece here will bolt on there, so it's easy to remove. And then you see lined up with the hole is the magnet, and then this goes through the hole, and then there's a nut each side, so you can use that to move it in and out, so it's really close to the magnet. But right, so there it is, made all tidy. The gap there's about 1 millimetre. Right, this is the troublesome blanking plug where I plan to fit the temperature sensors, and from all the forums I've been on, it states that this is an NPT, an American National Pipe thread. You'll see that the taper on it is, if my camera will get into focus, the taper on it is, well, it's not really a taper, it's parallel, isn't it? Whereas on the sensor, it's tapered. Now it will go in about 1.5 to 2 turns. With some thread sealant that might work, but it seems a bit rubbish, doesn't it? So I'm still basically still struggling with temperature sensors. So these were the other ones I had. You see they're also tapered. So I'm not quite sure what people use. I'm going to have to do some more research. We'll get there in the end. But that's definitely not a tapered thread. So I looked up, there's 2 threads which are very, very, very similar in dimensions. And you've got to remember, this engine was built, this engine was put in a vehicle that was built in Dagenham in the UK from parts shipped over from America. So did they tap a different thread into that than you might find in America? Some of the French vehicles have a different thread there, I've read. I don't know if this is true. So I've ordered 2 bolts to test what thread this is. And the first of them is this one. This is 5/8 UNF. And if you stack them next to each other, I don't know if you can see this, the threads are, you can't really see it, but take it from me, the turns per inch are exactly the same. If you hold it like that and match them up, they're exactly the same. The diameters, well, they're pretty close, aren't they? So let's give it a shot. So I ordered this bolt just to see what I'm trying to work out what this thread is. The cheapest way was to order a bolt from a specialist supplier and then see if it goes in. I did just, hang on. Right, well that's going in pretty easily. Right, we're in about 4 or 5 turns. It's still going.